This video is about linked lists, about pointers, and about looking for the errors that you usually make when we implement linked lists. Just some tips how to debug the problems and how to use the tools for that. First, I start with a linked list. You probably already seen a video or you had a lesson on this. Linked list, very similar to array, just more flexible and uses more memory but has more flexibility. How does it look like? We have some elements here, and those elements are connected through next pointer. I created a linked list which is pretty simple. I thought it's probably the smallest I can create. This is the element, so this is not T structure of C, is the element of the list. The next is the pointer to the next element, and so on and so on and so on. When we talk about linked lists, it's always important to know, and also during programming, where is the beginning of the list, so the head of the file of the linked list, and where is the end, which we usually specify by putting next element of the last to null, to 0. I'm going to show you a small program which is actually here not to copy or whatever, because this is not a really nice program. It's just a demonstration program to show some common errors the students do when using linked lists. Okay, I hope I can get everything on the screen. So what I actually did here was, in some a little bit stupid way, with hand creating 4 elements of a list. Normally I would of course use a loop and array for that, but just to make it clear, I created 4 elements. First thing I want to show is that how do I create these elements? So we use this structure node, and for the list we of course normally need dynamic memory, so we use malloc function to allocate memory on the heap. When we call malloc function, we call it with a size that we want to malloc. Now size is the size of the node T element, so it's the size of 1 integer and 1 pointer. Once malloc is executed, element 1 in this case will get address to the heap. If malloc is not successful, it will get 0 pointer. I think it's a good practice to always check on whether malloc already really allocated the memory or not. This is especially important with embedded systems because there are so many errors when people allocate memory and there is no memory anymore. It will give you back 0 and you don't know because you didn't check, and you are going to the reference 0 pointer, which can really give problems. Okay, so once we allocated these 4 elements, I will put element 1 data is 1, 2, 3. I actually didn't initialize element 4 because I want to show you some errors, and I'm going to connect them. So element 1 is this one, the next will go here, and the next of element 2 will go to next element 3, and so on. Now we are going to loop through this and just to do something very simple, print the data. Okay, this is actually now the head of the list, so the first element. What I'm going to do, I will just make this file. It is already here. I will make it clean just to be sure I have the most up-to-date file, and I'm going to run it. And I actually expect maybe there will be error, maybe not. We will see. There is definitely error, but I'm not sure whether the program will crash. Okay, the program is not crashing, so it works well. We are going to look inside. By the way, there is still error in this. And we're just going to watch what's happening. And that's the nasty way of C, because sometimes it can crash and sometimes not. And if it doesn't crash, it really doesn't mean there is no memory error. It really is dependent on which part of memory you are accessing with a wild pointer or initialized pointer. So we go just through this code. I created 4 elements. Normally, this should not be a problem. I link them together and I put next to the element 1. So let's go and have a look at what's inside. Okay. So as you can see, the first one has the value of 1, and it goes to the next, which is probably element 2. Just have a look. See, it's the element 2. Okay, it's the same number, so the same address, and so on and so on. What's pretty strange, actually strange, difficult to say, is that element 4, we did malloc of it, but all values are 0. So hurrah, it's initialized, we don't have to do it. But it's really not true, because there is completely no guarantee that this will be 0. So if it is 0, it's probably because operating system put all the values to 0 for the heap, but there is completely no guarantee about this, so we always have to check. Okay, so let's go and read the value. Okay, just the first one, second one, third one, and of course there will be no problem because as we have seen, the last data is 0. So we think, oh, it works. To be really sure whether our program is okay, we can use a Valgrind tool. And now we are really going to look whether it works. So what I'm going to do is Valgrind list. It's my program. And it shows 7 errors. Okay. By the way, it shows the leaks. We are going to look at them later on. And if I look at those things here, printf, blah, 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 this is the very important one. Use of uninitialized value of size 8. So actually, that means if I look at the code, we are in main.c, we go to the number 35 here. So we are printing something of the data, which is never initialized because we never initialized element 4. So even if it works and it's just by accident because there is a 0 value, it doesn't mean that the program is correct. So it's always good to, of course, to program well, but it's quite difficult to always find all these problems. So Valgrind is a very nice tool to help you with this kind of errors. But let's have a look and do something funny. What I'm going to do is actually, I'm going just to put this to 0. Okay, so there will be no element 4, but I'm still going to read 4 elements of the list. And in this way, I'm going to force the program to go and read 0 pointer, because this is the really most common problem probably what I see during assignments with linked lists. Nope. So let's do it again. Make. We can do Valgrind. Okay. Again. The heap definitely used. Error summary 1. Error. Okay. Invalid read of size 4. So again. See? This is not good. Doesn't like it. So there is something wrong. If I just run it, I really expect that I will get error now. This, and it's called segmentation fault. Means we are reading some uninitialized or warped memory. And I'm showing you this because sometimes students come to me and say, oh, I got segmentation fault. I have no idea what to do. What is it? So what you can just do, again, you just take the debugger, go to the list, and you run it. And if you really didn't crash memory very, very, very badly, it should stop at the place where the crash happens. So let's have a look. It's stopping at the line 35. And I'm going to print next. And it's 0. So what you're actually trying to do, you are trying to read 0 pointer, which is not good. Yeah. So what to do with this program? We can just say we are going to stop at 3 or so. So we are not going to 4 elements because there are no 4. And they should be completely okay. I'm going to build it again. Start the Valgrind. No errors. Of course, there are still eggs. We are going to talk about them. But there are no uninitialized memory reads. Okay, so we don't go to the fourth element which is not initialized. Actually, I just cut it off by removing this is sign. Okay, so that was about the reading of uninitialized and null pointers. What also happens sometimes is reading of the free pointers. But before we go to that, I'll show you what's wrong with this program. You see, definitely lost 32 bytes in 2 blocks. That's the memory leak. So, and that's also something what happens many, many times. Well, in program simple like this, it's really simple, but if you have complex program, it's difficult to find out where you malloc something when you free it. So we have to be extremely careful about it. Any memory allocated from the heap will be there until the program ends. And sometimes you just don't want that. So what we have to do is just for every malloc that you have, at the end, when you don't need the memory, you free it. Okay, so let's build it again. Okay, now the Valgrind is not complaining at all, so everything was freed. Good. It's also a very simple program, so it shouldn't be a problem. And when we freed everything, I'm going to show you the last error that I see very often is reading of the freed pointer, because when you free a pointer, you are not allowed to use it anymore, and that's what people do very often. So I'm going just to use again print whatever element is and I'm going to use the freed element 1. And again, if it's still on the valid address, probably it will not crash. But maybe when you run it next time, it will. So it's a very unpredictable situation what you are creating when you are going to read freed pointer. So let's have a look whether it crashes or not. But I did something wrong. Of because I have to put data here. Now, let's just try the list first. Okay, it just worked. So probably the address of this element 1 was still valid, but if something else was between there, some other program, it could use this memory to which element 1 is pointing, and then it will be not good anymore. So let's also use Valgrind to look whether this is valid what I'm doing. And you can see, again, invalid read all size for at main 42 here. Okay, and you can even see that this address of size freed. So you can see that you are already reading freed pointer. Okay, so that's also an error that's happening many times. Now let's remove this. And I'm going to do something even more crazy. That's the very last one. I'm going to create some infinite loop. So what I'm going to do, I will put this one to the first one. So actually this pointer is going here. Yeah. Now I'll show you some other way and most usual how to go through a list. So I will just remove this 4. Yep. And I will make a while with that's the usual normal way of reading the list. So we go through the next, through the next, through the next, through the next until it's 0. Okay, but now it will not be 0. So I think we are going to create an infinite loop. And I didn't save it because otherwise Nick should see that I did something here. Yes. Now, so let's run it. Okay. Now I'm using print. So it's just going on and on and on and on. But sometimes you have no print, and I see that students are just see their program hanging. Okay, so what you can do actually, when your program hangs and you have no idea what's happening, again, you start GDB, you run it, and it's hang, and you just press Control C, and then you can look where you are. Well, now you don't see so much, so just go up to the stack frame. Okay, and you can see that you are here. And that's exactly the loop. And of course, in this program, it's very easy because we have only one loop. So we know why it hangs and so. But if you have a very complex program and it's just hanging somewhere, you have no idea what's happening, it will show you exactly the place at which the program is. And of course, by looking at variables, you can see what's wrong. So maybe that's also interesting to show you. I see I used up function. It's just to go up one function. Up. Again, it will go to main, so it's the most one. And you can go also down with the stack frames. It's the printf. And sometimes you see also something like students come to me, why is this showing this to me? Because we just didn't build the printf code with our executable, so it's trying to go inside of printf code, but they can't find it. So, okay. Now, just for the last, just to make it really the way it should work. So we are going to put the tail of our list to 0, and now it should work. So probably it should just hopefully go once and without any memory leaks, any memory crashes. Let's do Valgrind. no errors. So if you see something like this at the end of your program, then you know at least that your program is memory safe. Of course, I can't say that it's functionally correct, but it is memory safe. And that's all I wanted to show you about the debugging of the pointers, about using of the Valgrind and GDB.